Good afternoon and welcome to the Water Research Foundation's webcast. The title of today's webcast is Management and Technology for Prevention and Mitigation of Legionella. My name is Grace Zhang. I will be a moderator of today's webcast. The Water Research Foundation hosts a three-part webcast series on the Legionella as part of the outreach of the Legionella Management in Building Water System Conference that was held in May this year. This is the second in a series of the three webcasts on mitigation and control of the Legionella in building water systems. All three webcasts are free and open to the public. We hosted the first webcast in September about analytical and monitoring method for Legionella in building water systems. If you would like to access the on-demand webcast and presentation slide, please visit our website and click the resources page. Then you will be able to find the recorded webcast and slide. I would like to introduce our speakers today. Our first speaker is Dr. Joe Catrubo. Dr. Catrubo is a president of the Joseph Catrubo and Associates Water Environment and Public Health Consultant in Washington, D.C. He is board certified in environmental science and a longtime member of the WHO's Guidelines for Drinking Water Quality Committee. He serves on numerous advisory panels on drinking water quality and water reuse. He is also a technical editor for Journal of AWWA, Water Science Journal, and Water Technology Online. Our second speaker is Dr. Frank Sideri. Dr. Sideri is a technical director at Special Pathogen Laboratory. He oversees a multidisciplinary teams to provide Legionella solutions, which include the water safety program and facility audits, disinfection assistance, outbreak response, and engineering support. Mr. Sideri has more than 18 years of experience in all phases of the water engineering project with specializations in water quality and Legionella. Our last speaker is Dr. Sheldon Masters. Dr. Masters is an environmental engineer at Corona Environmental Consulting. He focused on the drinking water treatment and distribution system water quality. Before we begin, I would like to announce some housekeeping items. Today's webcast will last 90 minutes in total. The webcast is being recorded. The recording and a PowerPoint slide will be posted on the Foundation website within 24 hours. At any time during the presentations, you will be able to send us questions using a question box on the lower left of your screen. Please feel free to submit questions at any point during webcast, but we will wait until the end of the webcast to answer your questions. Immediately following the webinar, you will be directed to the follow-up survey. Please take a moment to answer those questions. Without further ado, Dr. Catrubo, please take away.
Okay, thank you, Grace. I'm just going to say a couple of words of introduction. If you were not a member of the previous group, you may hear something new. We all know that Legionellosis is a very significant waterborne disease issue. I think it's the most significant because it's the only one that kills people these days. There are thousands of cases. Some portion of those are water associated. We don't know how much, but according to some VA statistics, their guess was about 5%. And I always mention that Flint got lots of notoriety because of lead, but actually the harm that occurred most likely there was 87 cases of Legionellosis and 12 deaths. We know that the risk profile is elderly, smokers, immune-compromised, medical treatment, people in IC units, hospitals, long-term care facilities, etc., where many of those characteristics exist, and therefore they are high risk. And so the highest priority, I think, is to be dealing with those kinds of facilities, and then and then seeing how we can extend it. This is a photomicrograph of the inside of a transmission pipe. Those are not necessarily Legionella organisms or Legionella pneumophila, but it's clearly an environment where bacteria can proliferate. And certainly biofilms is the primary environment that we know of inside of plumbing. And there are lots of factors that contribute to biofilm prevalence and formation and survival. But also there's a need for a lot of information therefore to try to help people decide how to evaluate those environments and make good decisions on how to minimize the risks, eliminate the biofilms as best as possible, and reduce Legionella counts if they're occurring. And interestingly enough, as we learned from our symposium in May, there really isn't a health basis for choosing a concentration because the exposure factors are so varied, as well as the susceptibility factors are highly varied, but a kind of a benchmark practical value that people are using, especially in Europe, is 1 colony forming unit per ml or 1,000 per liter, which sounds like a lot, but that seems to be a consensus number these days. Well, how does this stuff get into the plumbing? I think one of the major sources is water main breaks. When something like this happens, where bacteria that are in the mud have the opportunity to flow back into the pipe, and it certainly provides an opportunity for seeding and therefore ultimately proliferation. So we have 2 fine speakers today to tell you about their experiences on technology, Frank Sidari and Sheldon Masters. So take it away, Frank.
All right. Thank you very much, Joe. And good afternoon, everyone. Again, my name is Frank Sidari. I'm the Technical Director at Special Pathogens Lab. Appreciate everyone taking some time to join the webinar today and to learn a little bit more about Legionella. What I wanted to have an opportunity to talk to you a little bit about today is basically kind of a thought process on how we walk through thinking about Legionella prevention and mitigation strategies. So often when I'm speaking with individuals, people kind of just want to jump straight to a question about a supplemental disinfection or put in a system right from the start. But I think it's really important to understand why you might select a disinfection approach or the need for a supplemental system or a certain mitigation approach, and not just kind of jump to the end of the story. So I'm going to provide an opportunity to kind of walk through some of these thought processes, hopefully get people thinking about this a little bit more. And then Sheldon, following me, will be providing some case studies and additional thoughts on the subject. So with that, let's get started on determining when action is needed. And so the picture here is actually a plate in the laboratory that Legionella is growing on. That colony forming unit per ml that Joe showed in this slide and you might see on lab reports actually comes from the laboratory. So when they spread the water on these plates, everywhere you see a dot there is a colony of Legionella grows up, and that gets you the colony forming unit that you'll see on a laboratory report. So I thought I'd share that with you when we start thinking about Legionella. So as an engineer, if we think about our building water systems, ideally our buildings that we have are basically designed to grow Legionella. And there's lots of different reasons for that and things we can think about. And it's these challenges that we have when we think about mitigating and controlling Legionella that we're working within these kind of dynamic or living building waters. And so they include, piping systems, and there's certainly been discussion on pipe system designs, how they may be oversized for current flow rates and usages, very high surface area to volume ratios in these pipes where you have lots of opportunity for corrosion byproducts and sediment to accumulate, and of course, biofilms to grow in these systems. Also, in our water systems in our buildings, we have this naturally kind of warming of water. Whether it's heating water, such as potable hot water, or other non-potable systems, decorative water features, whirlpool spas, cooling towers, all of these things kind of naturally warm the water. And this warming of the water brings it into temperature ranges that are ideal for Legionella to grow in. And this is particularly concerning when we think about scald protection regulations. So in one instance, we're trying to manage our water temperatures to prevent scalding. Sometimes also manage our water temperatures for energy conservation and energy codes. But when we do that, we often end up with, again, circulating water systems that are at an ideal temperature for Legionella to grow in. Once we're in our buildings, we also tend to increase our water age and generally slowing of the flows. So out in the municipal distribution system, there's hydraulic mapping, and we try to pay attention to making sure that we keep lower water ages and water moving through our systems. But as we get into our buildings, that water often slows down. And some of this is because we have older buildings with oversized piping, less water being used, whether it's conversion to green fixtures or codes that have changed the flow rates coming out of the fixtures, switching to non-touch or those electronic sensor faucets that we see in public restrooms and other places. And within healthcare environments where there used to be a lot of hand washing going on, there's also switching to disinfectant gels. And even, when I'm at the airport, often instead of washing at the sink, I might use the disinfectant gel on my way out instead. So we're starting to kind of slow down the water usage and the water flows in our building water systems. And all of this kind of ends up being coupled with a generally low disinfectant residual. So typically a lot of municipalities are providing chlorine as their primary disinfectant. And we know in general chlorine may not be the most effective for Legionella control. We'll touch on that a little bit here later. But that residual that's being provided at the building meter or tap isn't necessarily being placed there to control Legionella. It's there to meet other disinfection requirements. It's there to kind of prevent disinfection byproduct formation at excessive levels. And once these disinfectants such as chlorine get into our building water system, again, where it slows down, is exposed to more biofilm, is warmed up, often those disinfectant residuals begin to disappear in these warm water systems where Legionella are growing. So overall, when we think about, kind of our buildings, we immediately need to consider these, and these are things to investigate and think about when we think about mitigation approaches and supplemental disinfection. So how do we actually determine our risk to building occupants? And this is a quote that we often share, came from Dr. Bruce Dixon, a former director of the Allegheny County Health Department. And he basically said this, and this is the idea of folks not being proactive when it comes to Legionella. If you don't look for it to determine your risk, you're not going to find it. If you don't find it, you don't think you have a problem. And if you don't have a problem, you don't do anything about it. And so what's happened with Legionella to some degree is that there hasn't been this proactive effort to identify it. And often we're dealing with kind of outbreak or case investigations where folks are being very reactive. And that's oftentimes where the jump comes to, hey, we need to do a mitigation or a supplemental disinfection because of the reactive nature of some of these investigations. So as Joe also mentioned earlier, when we think about when we need to take some type of action, we need to kind of, I think about why we're doing that. And so Legionella is a bacteria, and it's a bacteria that's common in our building water systems. But we're not really trying to eliminate Legionella from the world. What we're trying to do is prevent disease. We're trying to prevent cases of infection from occurring, from disease from occurring. And so I think that's an important concept or idea to keep in mind when we think about mitigation and supplemental disinfection approaches. And so the dose rate or the health-based, concentration for disease to occur is unknown. But we do know that zero Legionella may not necessarily be needed to prevent disease. And this has been shown in a lot of different publications. And in potable water systems in our buildings, what has been shown as kind of a risk factor is the number of outlets or the number of locations where Legionella is found. And in particular, a strain of Legionella that is more causative of disease, such as Legionella pneumophila serogroup 1. And what these studies have kind of shown is that it's more about how often or how frequent may somebody be exposed to Legionella as opposed to a one-time sample and a concentration or a number in there. And some of that has to do with sampling methods and how dynamic our water systems are and how the living, the micro environment in those faucets kind of release organisms when we sample. So we look at this as a potential indicator of determining when action is needed. And here's how it kind of looks like, we'll say in the real world. This is a facility we worked on, and the blue bars here represent samples for Legionella. So at the far left-hand side, the samples that were collected were 100% positive, 27 out of 27. And they performed some mitigation. In this case, it was a shock disinfection, and it dropped the Legionella, and it grew back as was expected. And eventually, though, they installed in this case, a monochloramine system, a continuous supplemental disinfection. And the dotted line here that you see is this 30% distal site positivity that I spoke about. So they were able to, with this mitigation approach, not necessarily eliminate Legionella, but control it well below that 30%. And what's real important here is that before they implemented this supplemental disinfection, they had multiple cases of Legionnaire's disease occurring at this facility. They were able to mitigate the Legionella with a supplemental disinfection approach, and they didn't eliminate or sterilize the water system, but they were able to control it to a point where they've had no more cases of Legionnaire's disease occurring at that facility. So it's important when we want to think about this that the ultimate objective here is to protect public health and to prevent disease. And that's one of our missions here at Special Pathogens Lab, is really to end Legionnaire's disease. And it's something we can do when we kind of take these thoughtful approaches to controlling Legionella. So I'd like to say, before you act, kind of understand. Don't just kind of jump to the end product, but ask some questions. And so some of this may go into what type of Legionella is in the water system. Is it a pathogenic species? Is it just at a couple of locations in the basement, or is it widespread throughout the facility? In the last webinar, I think, covered some of the testing methods and thinking about kind of looking and doing this environmental surveillance. Do you have a case of Legionnaire's disease associated with the facility? So this becomes a little more reactive. If you're in a healthcare facility, have you been looking for Legionnaire's disease? Some folks may not be looking as much as others. Do you have susceptible hosts? Are you a place that has a kind of a congregation of individuals that may be more prone to disease? And Joe mentioned a few of the factors of susceptibility there earlier. And then finally, are you operating your building water systems efficiently? Are you doing the best you can to, keep the water turned over, maintain good residuals, keep the temperatures where they need to be? So this isn't kind of a new idea, and this has actually been around, and so this graphic's kind of hard to see. But back in 1997, Allegheny County actually provided this proactive approach. And here it is kind of drawn out so you can see it a little bit. But they, kind of went through those same type of questions. First, did you look for Legionella? Did you find Legionella? If you did, have there been cases? Has it been greater than 30%? So you'll see that number, reaches back almost 20 years now, using that as a risk indicator. And they work through kind of that set of questions to understand, do you need to consider a mitigation approach or disinfection, or should you just continue environmental surveillance? And, now with ASHRAE 188, we would say, continue your water safety program. But it's this type of thought to walk through your prevention program to think about when do you need to apply supplemental disinfection, that you should be kind of taking these steps and answering these questions. So we'll assume you've kind of made it through that step in your head and you're on to, okay, now I might need to do some type of mitigation, or I'm really interested in doing that. And there's a couple of mitigation approaches out there. So when we talk about disinfection, you might be thinking about water system startup or commissioning, and I'll touch on each one of these here in a couple of slides. A reactive approach, might call it short-term disinfection or a shock disinfection, or are you looking at a proactive strategy to provide continuous or long-term disinfection? So let's dig into each one of these a little bit more. So first, when we think about that water system startup, this is typically associated with either new construction or system repairs, or it can be associated with seasonal equipment. So we see it quite often with cooling towers that may be off for the winter, or same thing with humidifiers and water features in spas and pools. So these are all pieces of equipment that certainly can have Legionella growing in them, that can support that growth, but maybe shut off for part of the year, be stagnant for months at a time, and then brought back into service. So we want to think about how do we treat or mitigate Legionella in these new or started up systems. And the ASHRAE standard, ASHRAE 188, actually has a section in it. It's a very small piece in the back, but take a look. We're not going to dive into that today. But it does talk about, for new construction, renovation, refurbishment, and even startup and shutdowns of these various water systems, that there's things that the water safety team should think about so that before you bring that piece of equipment or that building water system into service or occupancy, that you've taken the right steps to reduce the potential or mitigate the potential for Legionnaire's disease to occur. So that's all the time we'll kind of spend on those new systems. The disinfection or the mitigation, as I said, is kind of broken then into two parts, and I'm going to focus on potable water, drinking water systems. There are other, things we could go down for the non-potables, shocking swimming pools or cooling towers, but we're going to focus on potable water systems for today's webinar. So when we think about these reactive or short-term approaches, these are typically performed in response to something. So you have an outbreak or a case of Legionnaire's disease associated with the system. And these are one-time events, and the idea is that you're trying to rapidly reduce the amount of Legionella that's in a building water system to minimize the further transmission or risk for disease. So it's a one-time quick thing. What you want to think about is that, once this shock disinfection occurs, you reduce the level of positivity. Once that disinfectant's no longer in the system, Legionella often rebounds or regrows if you're not doing anything else to provide control. And we saw that earlier on the chart where they did a disinfection, the bar went way down, it regrew, and they needed to provide a long-term one to provide that lasting control. The options out there, and I'll touch a little more on these in a couple slides, but generally you'll hear of something called thermal eradication or heat and flush, hyperchlorination, and then there's also the ability to use a short course copper silver ionization has been shown in the literature also as a kind of a short-term mitigation approach. The other one, the kind of big group that we talked about then was the proactive or long-term mitigation. And so these are ones that you do to provide lasting control for Legionella. And so they're kind of, again, thinking back to that flow chart. You're responding to a high level of positivity, greater than 30% positivity, or you have a lot of Legionella pneumophilus serogroup 1 in a healthcare facility. Have you had a case or a suspected case of disease and you have some Legionella positivity? So then we go back to that flow chart to understand when we may need to provide this long-term control. And the idea behind these is they provide a continual disinfection to minimize Legionella colonization in the water system. So they suppress growth. They may not eliminate Legionella entirely from the ecosystem, but they suppress the growth of it so you don't have high levels of exposure going on. And there's a number of different options here, and we'll touch on these also in a couple slides from now. But the big four that often get mentioned are chlorine, chlorine dioxide, monochloramine, and again, copper silver ionization. And there's a couple other mitigation approaches that are out there. And so you'll see these listed, and they kind of might fall in a couple of the categories. So I put them on their own slide, but point-of-use filters are an option. So point-of-use filters are not necessarily going to provide a kill, but they're often used both in short and long-term approaches to provide a barrier to prevent transmission. So you may still have Legionella in your water system, but it prevents the exposure of individuals to the water containing that Legionella. Ozone and ultraviolet light, UV, are also written in the literature, and both of them can be effective at killing Legionella. In a building water system, however, neither one of these provide a very lasting residual that moves itself from the source water to the outlets. So these often have limited as a primary disinfectant in a building water system and might be used more as a polishing or a tertiary disinfectant in some very sensitive systems. And there's other technologies out there, and I'm not going to name or talk about too many of those, but this is part of what you need to think through in these next few slides, is that when you might hear of another technology or a claim by a vendor that their product can work, is what is the thought process you need to go through to validate that technology, and maybe it isn't a valid option for control of Legionella in your building water system. So let's think about some of these selection considerations when we're looking at a mitigation system. Again, you want to kind of understand that technology before selecting. So whether it's one of those major four I talked about or some new technology, I think the first thing you want to think through is that, is there evidence to demonstrate efficacy? And even within a group of disinfectants, there's different types of technologies used to generate some of these disinfectants, different manufacturers of products, just like we have different pumps, different pipes. So you want to look at those generation technologies and make sure that there's evidence that particular product is effective at specifically controlling Legionella. What might be the impacts to water quality? So this may be water quality or chemistry. Could that disinfectant interact with a certain type of pipe material or a certain type of gasket or rubber material that's in your water system, certain metallurgies, interaction with different types of scale or water chemistry that you have? So you want to look at those certainly in respect to what water quality and building water systems you have to see if there is going to be any potential interaction with the water or the components of that plumbing system. What are the manufacturer's operating ranges? So do they kind of meet what's required in your water system? Again, some of this goes back to water quality, water chemistry, point of application. But are you able to achieve then that operating range within that water system to be able to still meet drinking water criteria and still be then effective at controlling Legionella? And we often need to think not only about the primary disinfectant, but also the impact on the potential formation of other disinfection byproducts. You can't always just ramp up the disinfectant concentration as it may in fact impact those byproducts and might limit you as to what kind of range or dose you can provide. And that kind of goes a little bit to this ability to maintain an effective residual. Earlier I mentioned, is the water system operating efficiently? So one thing I'll say is, if you're not able to deliver hot water, for instance, through all of your distal outlets, you're going to be challenged in actually delivering then an effective disinfectant through all of those outlets. Or if you have a storage tank that, you can't get a good residual out because there's issues with turnover or stratification or sediments. These are all things that you need to think about in maintaining that effective residual when you're looking at what biocide that you're using in your system. When we look at the various technologies that are out there, these are kind of the 4 steps that we like to, evaluate that technology by. So when you look at any of those, you ask questions, in a laboratory setting, has it been shown to kill Legionella? So can I put a little bit of chemical X and Legionella in a beaker? Does it show to be effective? Is there anecdotal experience out there with individual water systems that have installed the technology and used it successfully to kill Legionella? Are there peer-reviewed studies or controlled studies of prolonged duration documenting that it's both been effective for controlling Legionella, but most importantly, for preventing Legionnaire's disease? And then finally, the longer that we can see these systems being used, are there confirmatory reports published showing multiple water systems having efficacy with a particular technology? So for kind of some of the new and arising technologies out there, these are kind of the steps that you like to think through in your head to see where are we at and what would be our risk of using this technology, how well do we understand its efficacy and its interaction with building water systems. So think about these when you think about selecting a supplemental or a mitigation approach. The other thing I kind of want to talk about is the point of treatment and selecting where that application point is. And so when we think about treating for Legionella, we can often most effectively do that by treating just the hot water. And you'll see here on kind of the comparison is this is what we think about when we're trying to control Legionella. And so that's the idea behind these mitigations, is if that's the primary reason why we're installing a particular technology, is by treating just the hot water, we can treat where Legionella typically grows. So it's the system that has the water temperatures, the circulating system where Legionella is going to amplify the most. We can maintain that residual in the hot water the best. Often when you're treating in just the cold water, you might have to get higher levels in order for that residual to last all the way into the hot water system. We treat the fixture. When we're treating on just hot water, it's often a smaller equipment size, less chemical usage, less cost for the facility because we're treating a smaller volume of water. We're no longer treating the water that's flushing the toilets or going to HVAC equipment that we may not need to treat for Legionella control. Again, chemical usage is low, and we're also exposing occupants to less chemicals, disinfection byproducts, just because they're not typically using cold or hot water as much for, say, brushing their teeth, hygiene, cooking, and things like that. So hot water application can be very effective. Most all of the literature that's out there that's looked at these technologies have been studies on hot water. There certainly are times when cold water application makes sense and might be the best approach, but it's something for the team to think about when you're selecting a technology because one may apply better to the other system. These abilities to maintain residuals I already touched on. Very complicated building water systems, lots of loops and risers and things like that. You need to get that disinfectant through the outlets for it to be effective. And again, if you're struggling to deliver hot water to all your outlets, you may be struggling to also deliver that disinfectant to those outlets. And the other thing is thinking about maintaining a residual. So in the hot water systems in our buildings, we're often able to put them on the recirculating loops, and we're able to stabilize and maintain a good residual. In cold water, just like in municipal water, you kind of have a one-shot deal to provide treatment as the cold water passes. So often we can, through a hot water system, maintain a more stable residual also. In the context of the regulatory realm, this is, I think, a very hot topic, and I only have one slide on it. So I'll bring this up here, is that adding treatment or some of these supplemental disinfection systems certainly can impact the chemical and microbiological quality of the water. Federal regulatory and state regulatory requirements may apply. Our experience is right now that at the national or EPA level, the guidance is not there, and it's often down at the state level for interpretations of the Safe Drinking Water Act, what type of technologies are accepted, what level of permitting and things are needed. So the only piece I can really offer here is that you need to understand your local requirements for permitting also when you're thinking about these different technologies and selecting the one that's going to work for a particular building water system. do your research. So kind of the end story here, and I'm going to present in a moment a few brief slides on each one of these technologies I've mentioned. But you can't get into the details of all of these. So there's really no one-size-fits-all technology. You need to take into account all of the things that I've just talked about and look at all the articles out here. You know, there's articles published in the peer-reviewed literature on these technologies, monochloramine, point-of-use filters you'll find out there. I've provided a couple articles in the Journal of American Water Works on chlorine dioxide, that's prolonged duration, a follow-up of 10 or 12 years after the installation on one system. And the EPA has also released a pretty comprehensive study here, I think it was a couple of years back now, looking at a lot of these, providing a lot of literature review, pros and cons and stuff. So there's a lot of information out there to make sure you understand what you're doing, again, before you go ahead and select one of these technologies. So these slides, as was mentioned, will be available, for review and to look at. So we're not going to spend a lot of time on each one of these, but I wanted to touch on kind of the basic concepts of a few of these technologies. So when we think about thermal eradication, these are time-intensive, short-term methods, raising the water temperature to 160 degrees, flushing every single outlet for 30 minutes is typically needed. This can help on the hot water side, but you end up with potentials for scald, very labor and energy-intensive program. Some facilities can't even achieve these temperatures because it takes so long because their infrastructure is not able to support it. And likely, again, with these shock or reactive events, you're going to have regrowth occurring very soon after. Hyperchlorination was another type of shock disinfection event, raising chlorine levels pretty high, 20 to 50 parts per million or even higher, some individuals use. Again, drawing that chlorinated water through every single outlet in a facility, letting it sit for at least 2 hours, reflushing all of that hyperchlorinated water out of the system. Again, this can be done on hot or cold, but you end up with water restrictions while this is in use because you have elevated chlorine levels, potential increases in corrosion with repeat applications, and again, you're going to have recolonization. As soon as that residual disappears, the opportunity for Legionella to regrow occurs with this. I mentioned point-of-use filters, and again, these can be used in a short-term application or in long-term applications. These types of filters get installed at the distal outlets or on an appliance outlet, such as an ice machine or a beverage dispenser, and they provide basically a filter as a barrier. And they require replacement. The manufacturers have different ratings on their filters, 30 days, 60 days, 90 days, et cetera. But they provide a barrier, can be installed very quickly, and can provide that transmission protection. The kind of the other four, supplemental disinfection, I try to put a little table together, and again, I can't touch on everything in the time that we have here today, but the idea with supplemental chlorine as a long term is you're generally providing a boost to the chlorine residual, often up to the EPA limit, so 2 to 4 parts per million. There can be concerns with additional formation of disinfection byproducts. These, chlorine can be fairly attractive since it's generally readily available. People are familiar with it. It's pretty cheap to install the equipment. But from a Legionella perspective, often we see concerns with inadequate biofilm penetration, corrosion of piping systems. Those disinfection byproducts could be elevated. And Legionella can be fairly resistant to chlorine. There's a number of papers out there that show up to 50 parts per million chlorine Legionella can still be resistant to, and it's in part because of its relationship with other organisms that are in the water system. Chlorine dioxide, again, the ranges are 0.1, 0.8 are typical application rates we see, again, up to the drinking water standard. The issues here are the disinfectant byproducts, chlorite and chlorate. And often in facilities, in particular with hot water, is you have trouble getting to that higher end of the disinfecting range because of the formation of chlorite. And chlorite being an acute byproduct is something we want to be very careful with. Chlorine dioxide does have excellent biofilm penetration and can be less corrosive, but because of the residuals being difficult sometimes to achieve, we've seen in studies that it takes a long time sometimes for chlorine dioxide to be effective, 18 months or longer. Monochloramine is another one that can be applied to the building hot water. Again, we can do this within the EPA drinking water standards, typical application range of 1.5 to 3 parts per million. Reduced disinfection byproducts when we think of THMs and HA5s compared to chlorine, so that's good. There may be some other concerns such as nitrification potential and other byproducts, in particular if you're just doing cold water application. But on the hot water system, the technology that's out there actually can balance recombine, we'll say, the chlorine. So We often, doing a hot water application using the technology that's out there, can minimize the nitrification potential as opposed to the one shot that you have through a cold water application. Monochloramine has also been shown to be very rapid in control of Legionella. Often just a couple of weeks of achieving that residual can provide control in our water systems. And finally, copper-silver ionization is out there. Again, this can be done within the drinking water standards for both copper and silver ion concentrations. There's no disinfection byproducts. Copper and silver are the two chemicals or metals that are placed into the water. So you have no precursor. It's generally a pretty small equipment footprint. There is some challenges with measuring silver. There's not a field test, so that's a send out to the lab. And there has been some anecdotal reports of pitting for corrosion, potential resistance, some pH stuff. Again, these are more details that need to be looked at in each building water system. But a very effective ionization has been around for a very long time, controlling Legionella and preventing disease. All right, so to wrap up here, how we integrate this with our building water safety program. So if you have chose to put in a supplemental disinfection system to help you mitigate or control your Legionella in your building, we want to make sure that it's part of this water safety program and it's being managed. And again, we're not going to go through ASHRAE 188, but it provides kind of these elements of the water management program and lays out these steps that you need to build the program around. And there's several spots here where we see the supplemental disinfection needing to modify or take a place in this system. So in your water system or flow diagrams, of course, you need to show where the supplemental disinfection system is being installed, where's the point of injection, what water systems are it treating. You need to develop what those control measures are, what are those concentrations of disinfectant that you're trying to apply, and where are those being monitored and how. And then what are those corrective actions? So if you have a low value or a high value, how are you responding to that? Is it an adjustment of the equipment? Is it additional flushing? How are you operating that system needs to be understood in the water safety team. And then documentation, of course, of all the records, making sure that you're not exceeding water quality parameters, complying with any permit that you may have been issued. The piece here that we want to understand is by installing this, we really need to confirm or validate, is the term used, that the mitigation is actually controlling Legionella. And the only way to do that is through environmental testing to really demonstrate efficacy. So, you can have your temperature maintained, you can say that you have a biocide residual of X or Y, but that's not necessarily correlating to say that the Legionella has been affected or is under control. So the recommendation to think about when you go ahead and implement a mitigation approach is to make sure, one, you have some baseline testing prior to startup. Yes, I had over 30% positivity. I installed the equipment. Within a couple of weeks after startup, did I check to see, is it working? Do I have the right residuals? Am I getting that effectively to the outlets? And then generally you monitor that periodically to verify and then to validate that the hazard Legionella is being controlled. After that, you may need to continue to make some adjustments to your monitoring schedule. You may tweak your concentrations, your biocide residuals. But the only way to do this properly is through validation that Legionella is actually being under control. And so I'll end here with the proactive prevention and mitigation approach. One of them that we see out there and we like is actually in New York State. I'm not sure if there's anyone from New York on the phone, but New York State public health care laws kind of thought through this process that I just went through. And so they require healthcare facilities up there to do an environmental assessment, do a risk assessment, look at the water systems, understand, do I have Legionella, am I doing clinical testing, all of that. Develop a sampling plan, sample for Legionella. Less than 30%, they continue to kind of maintain that sampling approach. Again, think back to that flow chart I showed you from 1997. If they've got more than 30%, then they can implement these short-term control measures, and these are the ones that are listed in the New York State law: thermal, hyperchlorination, short course ionization, resample to validate efficacy, long-term control if warranted, and then maintain that program. So it's kind of this proactive approach where we understand our water systems, we monitor them to understand if there's a risk or a concern, we react to that based on a control limit such as 30% positivity and respond by implementing the appropriate mitigation and following up on that. So this is kind of hopefully some thoughts for you to think about on how you want to approach mitigation and monitoring this in our building water system. And so those are my slides for today. I thank everybody for their attention, and we'll pass it along to Sheldon.
Thanks, Frank. So I'm Sheldon Masters. I'm an environmental engineer at Corona Environmental Consulting. I'd like to thank the Research Foundation for organizing this workshop and thank all of you guys for attending the workshop or the webinar. So what I'm going to be talking about today is building on some of what Frank discussed, but starting by looking at some of the factors that influence Legionella growth within a building plumbing system, talking about some of what Frank mentioned, but talking about that in the context of two case studies, looking at the compatibility of different types of disinfectant treatments, and also looking at thermal disinfection. And then finally, finishing by talking about potential trade-offs to consider when trying to control Legionella in building plumbing systems. So if we take a step back and look at how water quality changes from the source to the tap, in general, water utilities are really good at significantly improving or drinking water quality once it receives it from a source. It's usually a groundwater or surface water. And the further out we go in a distribution system, the quality of the water can decrease. This could be due to biofilm growth, stagnation, residual loss, or some kind of intrusion that occurs. And once the water enters the building plumbing system, the same kind of problems that we see in the distribution system are similar to those that we'd see in the plumbing system. The only difference is that in the plumbing system, these problems tend to be significantly worse. One of the reasons is because within a building plumbing system, there are these unique conditions, some of which Joe and Frank talked about before. One in particular has to do with higher water age in building plumbing systems. And this is mainly due to the fact that each building essentially acts as a dead end, where disinfectant decay can occur. You can have nitrification and regrowth if it's a chloraminated system, or you can have disinfection byproduct formation due to at higher water ages. The issues associated with water age are likely to increase. This is due to the adoption of more green buildings, installation of low-flow faucets and fixtures, and also changing consumer behavior with regards to water conservation. Comparing the premise plumbing to the distribution system, there's also differences in terms of the type of material that's used for piping network in the distribution mains versus in the premise plumbing. So in the distribution system, we tend to use iron or cement or large plastic pipes, while in the building plumbing system, there's a wide array of pipe materials that are used in the building plumbing system, including brass, copper, lead, PEX, and PVC, just to name a few. And some of these plumbing materials, for example, copper, can be extremely reactive with disinfectants in the building plumbing system. There are also unit processes within a building plumbing system that can change the water quality. So, for example, in the water heating system, so you can think of your water heater as a biological and chemical reactor where microbial growth can occur. So we can have extreme temperatures can cause the rapid disinfectant decay, and these can also create ideal conditions where pathogens can grow. Similar to unit processes that you might see in water treatment plants, sometimes in a building plumbing system, you can see similar unit processes such as GAC filters that are sometimes installed in building plumbing systems for removing certain contaminants or suspected contaminants. But that also could remove a disinfectant, which could be problematic in terms of regrowth downstream of these systems. The CDC has done a great deal of work in terms of investigating Legionella disease outbreaks, and from the work that they've done, what they've found is that about 2 in 3 cases of Legionella disease outbreak are due to some kind of process failure. So this could be a lack of a water management plan. About half of the cases are due to some kind of human error. So maybe somebody forgot to do something that they were supposed to do. About 1 in 3 cases are due to some kind of equipment failure, and about 1 in 3 cases are due to some kind of unmanaged external change. So this could be something that happened in the distribution system. And one of the things that Joe mentioned in his introduction was main breaks and things like that. And about 1 in 2 are due to more than one of the factors that were mentioned above. So what I want to do today is talk about some of what Frank mentioned in his presentation, but talk about that in the context of these two case studies. The first case study is looking at a hospital, and what I want to focus on is the compatibility of different types of disinfectants, which potentially cause a problem here. And in terms of putting it into the cause of why we have Legionnaire's disease outbreaks from the CDC studies, this particular case was due to human error, process failure, and also equipment failure. The second case study is a very interesting study that was done by Emily Bedard at Polytechnic Montreal, and this was looking at thermal control of Legionella, and this was the issue that was identified here was due to process failure as well as equipment issues. So in the first case study, we investigated a circumstance at a hospital, and in this hospital they had more than 400 beds, and the facility offered clinical, surgical, and specialty services. Because of the jurisdiction in which the hospital was located, they were required to have 3 days emergency storage. At this particular hospital, in addition to having 3 days emergency storage, they had additional storage they had a storage for the existing building, but they also had storage for 2 buildings that they were planning on constructing. So rather than having 3 days storage, they had more than 9 days of water storage at the facility. They conducted some environmental sampling for Legionella in both hot and cold water taps, and of the 11 taps that they sampled, about 45% of the samples came back positive, with a mean Legionella concentration of about 1,600 CFU per liter, and the maximum concentration that was measured was about 6,000 CFU per liter. And just to provide some context for this, several European countries have adopted guidelines and regulations that specify an alert level between 100 and 1,000 CFU per liter. And there's some consensus to set an action level at about 10,000 CFU per liter, at which point some kind of corrective action would have to be taken immediately. So in this facility, the water supply, so coming from the distribution system, was a chloraminated system. What we found was that there was about 2.5 milligrams per liter of total chlorine that was entering the property of the building and going into the storage tank that you can see here in this pictorial diagram. Within the storage tank, they also had, they were dosing ozone into that storage tank, and the residual leaving that tank was 0.5 milligrams per liter of total chlorine. The water then went through a softener where the residual dropped to about 0.2 milligrams per liter of total chlorine, and by the time it got to the building facility at the points of use, it was non-detectable residual. So here, what we found was that the main causes of the dramatic disinfectant decay in the storage tank was due to the presence of the ozone disinfectant. So in this particular case, the reaction between chloramines and ozone would result in the destruction of the chloramine residual. So these two disinfectants were not particularly compatible in this case. In addition to that, the use of ozone could create more assimilable organic carbon, which could be an additional food source for microorganisms. In the pictorial that I showed before, I showed a circular-looking tank, but in fact, it was more of a trapezoidal-shaped tank, so there was poor mixing that was going on in the tank. And as I mentioned before, they had additional storage, so more than 9 days of storage, so that created high water age within that tank. One of the things that we find when we go into these building plumbing systems to investigate something related to a Legionella problem is that there are potentially other problems within the building plumbing system. One of the other issues that we identified was corrosion problems with iron valves within the building plumbing system. And that was due to deposition corrosion, galvanic and deposition corrosion due to the presence of copper in recirculating loops. So one of the recommendations that we had was to switch the materials of those valves so to be a more compatible material with the dissolved copper that was in the building plumbing system. In terms of other recommendations, we recommended to drain and bypass the emergency tank temporarily until a disinfection boosting system could be installed in the tank. And when that bypass was done, what we measured was about 2.5 to 3 milligrams per liter of total chlorine coming into the facility and entering into the water softener, and about 2 to 2.5 milligrams per liter of total chlorine leaving the softener. However, when it got to the building plumbing systems and we measured residual at points of use, in some cases there was reasonable or good residual at points of use, but in other cases it was non-detect. So just by virtue of getting a residual to your building property line or into your building plumbing system doesn't necessarily guarantee that you'll have a residual at points of use. So our final recommendation was to take a holistic look at the building plumbing system and to develop a comprehensive water management plan in order to make sure that you have reasonable residuals at points of use and you're controlling or mitigating Legionella growth. In the second case study, this is focused on thermal control of Legionella. The chart here on the left is showing the different growth ranges or disinfection ranges for Legionella. So the optimal growth range for Legionella is between about 25 degrees Celsius to 42 degrees Celsius. Above that temperature, you may have Legionella survival, but the ability of the organism to grow is limited. And above 70 degrees, you have disinfection of Legionella. Most of the regulations and guidelines suggest that the temperature leaving the water heater should be about 60 degrees Celsius, and across the network, you should try to maintain 55 degrees Celsius or more throughout the system. So in this particular case study, there were 2 cases of nosocomial legionellosis in a 400-bed university hospital. An investigation was conducted for the 2 separate water systems that were feeding both wings of the hospital. So Wing A and Wing B, and Wing A has about 300 beds and Wing B has about 100 beds. And environmental investigation found that the hot water system was a source of the in 2 cases of legionellosis that were reported. So an environmental investigation and remediation was undertaken, and what was done here was thermal decontamination of each of the buildings, temperature diagnostics, and the temperature diagnostics were used to identify and prioritize risk areas in each wing of the building. Then control measures were implemented, followed by long-term monitoring. So the way that the thermal disinfection was carried out is very similar to what Frank mentioned in his presentation, where recirculation of water greater than 70 degrees Celsius was done for more than 30 minutes in all loops, and at points of use were flushed for about 7 minutes at water temperatures greater than or equal to 70 degrees Celsius. In System A, before the remediation was implemented, there were about 82% of the taps that were sampled were positive, and after the remediation, none of the taps were positive for Legionella. In System B, that was slightly a different case, where it didn't appear that there was a significant decrease in the cases of a significant decrease in measurable Legionella in System B. This could be because System B had a larger number of distal points relative to System A, so 2 separate interventions were conducted in System B, or it could be due to the initial levels of contamination that existed in the building. One thing that these researchers also did was to develop a temperature diagnostic approach, very similar to the diagnostic approaches that Frank mentioned in his presentation. And this flow chart that's on the screen here now is showing the stepwise process, starting from the principal flow loop that indicates the overall system risk, and then moving progressively to subordinate loops to identify large areas or sectors within the building that could be at risk. and then finally to the tertiary or terminal ends to identify local issues with defective faucets or showers or other fixtures. The diagnostic flowchart also proposes a stage response in terms of the corrective and preventive actions that have to be done, including monitoring for Legionella. Here, critical control points defined as water heater outlets, the principal return loop, and representative at-risk points of use are prioritized for sectors at risk that were identified in the initial risk assessment. And this stepwise approach can help to direct efforts towards high-risk areas as well as optimize resource allocation. So here we're just showing a diagram of System A and System B. And in System A, the water enters into the building and goes into a heat exchanger where it's heated to more than 70 degrees Celsius. And then the preheated water is stored in a water heater tank. And then it goes to a tempering valve where the temperature is reduced to about 60 degrees Celsius and then distributed to each sector of the building. The return loop temperature is about 55 degrees Celsius, where it's returned back to the water heating tank. In System B, there's a somewhat similar setup, except the temperature here in the heat exchanger is heated to 60 degrees Celsius and is then stored at 60 degrees Celsius. So there's no tempering that happens before it's distributed to the occupants of the building. And the recirc temperature, the return temperature, is about 56 degrees Celsius. So the loss between the water heater and the return loop is within the recommended values of 5 degrees C, which indicates good recirculation within the system. However, this only reflects the heat loss from the combined return loop, but doesn't really provide any information on the multiple subordinate loops within the system. So here I'm showing a diagram of continuous of System A. This is a map of the temperature distribution throughout the system, and this was done at 3 different times. There's continuous monitoring that was done at both System A and System B, but I'm just showing System A here because this is where the 2 cases of Legionnaire's disease were uncovered. So the continuous monitoring was done over a period of 2 weeks in both the primary and secondary loops. And as you can see from the diagram here, there's no relation between the temperature drops that occur and the floor numbers. So there's significant discrepancies between the temperature on each floor, particularly on the 7th floor, where the temperature here is about in 34 to 39 degrees Celsius, which is within those ideal growth range temperatures for Legionella. So one of the things that this highlights is how defective hydraulics at secondary loops can go undetected if temperature monitoring is only conducted on the primary flow loops and the return loops. So some of the potential causes that were identified here was for the drop in temperature at this particular floor in the building was prolonged stagnation in dead legs and low use, insufficient recirculation flow rate, especially in specific areas of that part of the building, flow inversion due to pressure variations during high demand, and mixing of cold water with hot water within the hot water system due to defective valves or convective mixing. So after remediation actions were taken, there was a decrease in the counts of Legionella over time. So this graph here on the y-axis is the concentration of Legionella in both genomic units per liter and CFU per liter. And the light blue box plots here are qPCR results, and the dark blue are culture results. And the boxes are 10th to 90th percentile, and the whiskers show the minimum and maximum values. And the white boxes are the medians. And you see that the medians for the culture results are more or less stable, but the variability is decreased over time. And for the qPCR results, we see a decrease in concentration over time. So some of the main conclusions were that the thermal disinfection resulted in a significant decline in culturable Legionella pneumophila in the system that was implicated in the Legionellosis cases. And a combination of enhanced thermal regime with other corrective actions, such as flushing taps weekly, removing dead legs, repairing faulty faucets, as well as properly insulating pipes, helped to further reduce Legionella pneumophila over time. But one of the key findings is that local conditions may drive the risk associated with Legionellosis, and that monitoring the primary loops could be somewhat misleading, and that a more detailed analysis may need to be conducted in some cases to really identify problematic areas. So one thing I just wanted to end with is that this presentation is focused on mitigating risk associated with Legionella, but I think it's also important to look at these issues holistically and consider other potential risks in the building plumbing system when looking at controlling Legionella and other opportunistic pathogens such as Pseudomonas or Emavium or other microorganisms. So some of the premise plumbing hazards that we have to consider are disinfection byproduct formation. This is one of the things that Frank mentioned, which is a particular concern with supplemental disinfection, or lead corrosion or other chemical risk within the building plumbing system. And looking at this, we also have to consider potential risks like physical hazards, like scalding in the building plumbing system. So if we look at this diagram here, that's going from left to right, you have Legionella survival in colder water conditions, and then at a temperature between 25 to 42 degrees Celsius, you have the optimal growth range for Legionella. At higher temperatures, you could have Legionella disinfection. But all other things being equal, you could have increased disinfection byproduct formation at higher temperatures. Similarly, within the disinfection range, temperature range for Legionella, that's also a temperature range where scalding would occur. So this is just trying to illustrate that there are potential trade-offs that have to be considered explicitly when trying to address the problems with Legionella in building plumbing systems, and we want to ensure that we consider explicitly all potential hazards that could occur within the system. So with that, I will hand things back to Grace so that we can get into the question and answer period. So thank you guys very much.
Great. Thank you, Joe and Frank and Sheldon, for the great presentations. As a reminder, you can submit questions by using the question box on your left side of your screen. There are several great questions coming from the audience. So first question is to Frank. This question is about the hot on-demand tank. So Frank, so would you recommend a hot on-demand tank at a local area? So what is your thought on this?
So I guess when it says on-demand tank, when that thought is there's two different things that could come to mind in the plumbing world. So in some areas, these on-demand tanks are just that, as more of like a little 2.5 or 5 gallon hot water tank. So sometimes these are used in, public restrooms or a kitchenette in an office or something like that. And then the other type that may be referring to by an on-demand tank would be more of what's considered an instantaneous or a semi-instantaneous little heater. Some of these are used, to generate hot water quickly for tea or something like that. So I think with both of these, there's a few items to think of, and I can't say that one of them is better than the other or better than a holistic system. So I think it needs to really be part of the overall design of the building. If you have, just a small area, a bank of restrooms and can serve that with a small hot water tank, you may be able to do that efficiently and reduce the amount of, circulated water volume, storage volume, maintain higher temperatures because you're not losing that temperature throughout a building. So I think there does need to be some attention paid in, we'll say, the engineering and design world to optimizing our plumbing designs I know there's, I think, some discussion within the code world of dealing with existing plumbing codes to, sometimes the plumbing code design doesn't allow us to, say, optimize for waterborne pathogen risk, we'll say. But one thing to think about with storage tanks and instantaneous heaters is maintaining those. So with those heaters, if they're not at a warm enough temperature, you certainly can be within a range that Legionella can grow. Some heaters, depending on how they're plumbed, the water can stratify within them, so you can get a zone of cooler water at the bottom and the warmer water at the top. You can have sediments begin to accumulate in some of these storage tanks, which provide nutrients and further insulation from temperature for Legionella to grow in. So I think on that, I really would be kind of a part of the team or the engineering team to look at the specific situation to determine what the best plumbing design would be.
Great. Thank you. The second question is to Sheldon. So do any of you, do you have any experience with the Legionella issue in buildings doing on-site reuse of the black water or gray waters? Will maintaining chlorine or chloramine residuals will be sufficient for the Legionella control? So what do you think?
Most of the work that I've done has focused on the potable side of systems and not particularly drinking water reuse. And with regards to which type of disinfectant would work, I think that would be a site-specific thing that would have to be considered. So I'll let Frank take that one since he has probably has more experience doing that.
Yeah, I think so. Specifically with regards to black water and gray water, then to me, this gets down to a little bit of how that water is being used. So part of what we want to think about with preventing Legionnaire's disease is kind of that chain or the mode of disease happening. So in order for a case of disease to occur, we need to have a reservoir of water, which supports a pathogenic, we'll say, strain of Legionella or a variety of Legionella in there. And then you need to have a mode of transmission. And that Legionella bacteria then needs to get from the water into the lungs of an individual. And then, of course, that individual needs to be susceptible to succumb to the disease. So when we think about, I think, sometimes of these reuses for black water or gray water, and maybe black water in particular, but I guess with both of these, I don't know if you're considering storm water, roof water capture in this also. But you, I think, need to think about both the storage of that water as well as the end use of it and what that potential or risk is for transmission to occur. So if you're just using this reuse water, black water, gray water, say for flushing toilets, the mode of transmission from a cold water toilet to cause disease is probably pretty small. If you're using this black water for a hot tub, then you may want to be thinking a little bit more about that. So I think it is important to think of the overall kind of infection, that chain of infection, and understand the risk and how that water is being used. With that said, maybe kind of as what Sheldon said, is the specific treatment for that water, I think would depend on a lot of items. Of course, what is the water quality and chemistry of that black water or gray water? What's the plumbing components? What kind of tanks are it being stored in? How long is it being stored? All of that would need to be taken into account to kind of pick one of those technologies that I talked about that may work the best for that particular system.
This is Joe.
Yes, Joe? Okay, I guess he has some technical difficulties. Joe? Okay.
Can you hear me? Hello?
Yes.
Oh, sorry.
Yes.
Okay. Just to comment on recycled water and reuse, I think it's important to differentiate between recycled water that is being converted into drinking water quality, and then recycled water that's being used for some lesser purpose, which receives much, much less treatment and also has a lot more nutrient in it. But for recycled water that's being produced for drinking water purposes, such as Orange County, keep in mind the organic carbon in that water is probably much less than than most of the drinking water supplies around. And so I'm thinking it's much less likely to be a concern for growth in that water, whereas for water that's being used for irrigating a golf course or something like that and being sprayed, which has less treatment applied and also higher nutrient levels, that would be a much greater risk concern. So I would be pretty concerned about locations where they're spraying partially treated recycled water.
Well, thanks, Joe, for the comment and the clarifications. There is a few questions about the UV technologies. I would like to ask to Frank, if UV technology is applied at the point of entry to a building, could it successfully treat any Legionella introduced through the water main break? What will be the risk of the Legionella growth or regrowth in the building after the point of use UV treatment?
Right, so it's certainly a good question. So UV, we'll say in vitro. So if we take a beaker of Legionella in the lab and put it, a UV lamp there, pass the Legionella across it, is effective at killing or inactivating Legionella. So we know there that UV certainly can be effective. When we start to apply it in a building water system, it can also be effective, but we need to make sure that we understand how it's being applied and what the objective is. So in this particular question here, the piece is could it successfully treat Legionella introduced through a water main break? And so I think the thing here that I would be concerned about in that particular case is the sizing and selection of that lamp, that when it was taken into account that it may account for, say, a water main break. So one of the items, generally, drinking water is fairly clear, at least to the naked eye. There is some suspended matter in there. But when we have a water main break, we often have very turbid water. And so that turbidity, I believe, can present a challenge, shadows and particles and other organisms that may allow some Legionella to pass through that lamp if it's not been properly sized. So I think if you're designing a primary system where you want to use UV in this type of application and your concern is, I have frequent water main breaks, that it would be something to talk with the manufacturer of that technology with. They certainly would understand their technology and these types of challenges and be able to provide you the best guidance on the selection. I know when we've applied UV lamps in a circulating hot water system, we've installed filters upstream of that lamp in order to try to remove some of the suspended solids and stuff in order to improve the efficacy of the lamp, maintain a clearer quartz sleeve and things like that within the lamp itself. So I think there are some design things you can do, maybe using UV in conjunction with a filter if you have very turbid water or water quality. But again, I think talking with the UV manufacturer would be the thing to do in order to make sure that they were aware of your concern and selected or sized something that was appropriate for that application. I might also say I think the second part I see on that question is about regrowth in the building after the point of use. So I did mention, UV doesn't provide a residual disinfectant, so it does all of its work as the water passes through the UV treatment unit. So we need to think about, Legionella and the potential for regrowth out in our building water system. And one of the challenges we have with, all of our buildings is that, existing ones already have established biofilms and things happening in there. And even brand new buildings that are newly under, construction or built, have organic material, have parts that have been wet tested, pre-manufactured, rooms and piping systems that get installed. So often our buildings already are kind of set up with some level of biomass and organic load in there, which may or may not contain Legionella. So there are some challenges, I think, in doing just a non-residual point of entry treatment that may be effective at the whole building. But again, the thing to do is thinking back to our proactive state is if that's the mechanism that you use for mitigation is to do testing of your building. So if you're testing, doing environmental testing, checking to make sure things are under control, perhaps you can use a technology that doesn't provide a disinfectant and still minimize the risk for disease. So it's all part of how you build that water safety program. And if I can, I'll just answer the other question was in regards to UV lamps within storage tanks, effectively avoiding any Legionella growth. And I would say the same thing here. So with UV lamps, if you're looking at trying to use them within a storage tank, again, this would be a question for the UV manufacturer. The sizing of the lamp would be important, how large the storage tank is to make sure you're effectively getting UV light to the areas that you want to treat. Would all need to be done. There are, open channel type UV systems and things like that treat larger volumes of water as opposed to piped water. But that would be something, again, to talk with the manufacturer about on your particular application and what your goals are and see if they could design a UV system array that might work in that storage tank that you were talking about.
Thank you. Well, that was the question that I was going to ask to you, but thank you. This question to the Sheldon. Well, aside from the Legionella, have you been made aware of a similar environmental cause of other form of the bacteria in building water system?
Yes, so there are environmental conditions within the building plumbing system can cause growth of other microorganisms. In some cases, these conditions are similar to the conditions that might cause growth of Legionella. The things that we would want to particularly control in terms of reducing microorganism growth for Legionella and other opportunistic pathogens would be the sediment, so making sure that we're reducing sediment and biofilm within the plumbing system. We're controlling temperature within the correct growth range. We're also looking at reducing our water age and maintaining our residual. And there are also some cases where we see trade-offs between the type of disinfectant that we'll use. So, for example, we've seen case studies where after you implement chloramine disinfection, you'll see a decrease in the amount of detectable Legionella because the chloramines are able to penetrate biofilms more effectively. But that change also tends to select for mycobacteria. So there is some kind of trade-off that exists as well, even in terms of the selection of the type of disinfectant and how that disinfectant might select for a certain microbial ecology.
Thank you. There is another question to you again. Have most Legionella outbreak been associated with the plumbing?
Can you repeat this again, Grace?
Yes. Yep, I can hear you.
I'm sorry, I was asking if you could repeat the question. Oh,
yes. Have most Legionella outbreaks been associated with the plumbing?
No, most cases have not been associated with the plumbing system. You might have individual cases that are associated with plumbing systems. Yes, there are cases that are of outbreaks that are associated with plumbing systems, but most of the cases have not been attributed to that source.
Well, this question to the Frank or Sheldon. So the question is about the copper-silver ionizations. So do we have any long-term peer-reviewed studies of efficacy of copper and silver ionizations?
This is Frank. There's many peer-reviewed studies out there on copper-silver ionization, and there's some that have been part of peer-reviewed literature, kind of looking at these installations that have been installed for many years. It would be something I would need to provide offline, but we could provide those references. I also believe that EPA document that I put up there, talks about ionization and would have probably some of those references too in regards to that technology.
Okay, great. Thank you. Well, another question to Sheldon. Can Legionella still formed in the building water that is moving and flowing? And we understand that the issue of disinfections residuals are being consumed in stagnant water, but does the flow water have a lower chance of the Legionella formation in spite of the concentrations of the disinfections? Could you comment on this?
So yes, you can have formation of Legionella in flowing water as long as you have the right conditions. So if there is not, so for example, if there isn't the presence of a disinfectant and if it's within the proper growth range temperatures for Legionella, you could have growth that occurs in flowing water. You might tend to have more growth within biofilms or within amoeba or other organisms that can host the Legionella, but it is possible for it to grow and amplify in flowing water as long as you have the right conditions.
If I can add, this is Frank, if I can add to that, there is one paper that I'm aware of that looked at Legionella growth in stagnant, laminar, and turbulent flows. I know it support what Sheldon said is actually in turbulent flows, Legionella grew very well. And part of that, when you can think about flowing water, they support different types of biofilms, but flowing water does a good job at distributing nutrients throughout the biofilm, has a healthy biomass and group of organisms growing there. But there is one paper that did look at that, and flowing water can support Legionella very well, turbulent flow.
That's great. So another question is about the responsibility of the utility. So as a water utilities, what should they do to prevent the Legionellosis among their customers? Any comments?
Yes, so I guess I'll comment on that, and I'll give Frank or Joe the chance to comment on that. So I think that there is a shared responsibility in terms of trying to address some of these problems, but in general, the responsibility of the water utility tends to end at the property line. So it's helpful if the water utility is working to provide a reasonable residual to the building owner. There is some assumption that was made in regulation that if you control particular pathogens at the treatment plant, then you'll also be controlling Legionella as well. I think that's probably not the case because where you have amplification taking place is at the building plumbing system. So an important part of the responsibilities for building owners to understand their building plumbing system and take necessary actions to mitigate risks at the point where amplification is most likely to occur, which is within the building plumbing system.
Frank, would you like to comment on this?
Yeah, I can. I certainly would agree with what Sheldon said, and I believe there is also a paper out that talked about an outbreak of Legionnaire's disease that was associated with a public water system. And there were some good, I think, points that author made in that paper about kind of some of the responsibilities that water utilities have. And they really just talk back to managing your system very well. So maintaining a water system, understanding, that you have water flowing through your mains, keeping your water storage tanks free of, heavy sediment loads, avoiding stratification of water tanks where you might get, a warming of the water to a point that might be able to support, Legionella growth in the summertime in the south or something like that. So I think just making sure that those things are done, maintaining a good flushing residual, keeping your residuals in your water system are important for the utility provider to do just to manage that well. But again, as Sheldon said, the Legionella issue really occurs past the meter. And even building operators that manage their water system well, the water, the pipes, the nutrients, the other organisms that are in there are often out of the control of those individuals. And so that kind of management falls on that building owner to do some testing, to implement a water safety program and manage the risk at that level.
Yeah. Grace, one thing that I'll add, this is Sheldon, is one way in which the utilities can help is by providing information to their customers in terms of what the roles and responsibilities are and how building owners can mitigate risks within their building plumbing system. And I'm using this as an opportunity to make a plug for a project that, a research foundation project that we did looking at customer communication around plumbing system issues, particularly Legionella growing in building plumbing system. And this was a project where Grace was the project manager, and this was work done with Jennifer Clancy, Samantha Villegas, and Martha Chevalier. So that's another way in which utilities can potentially provide assistance to building owners.
Yeah, so that's a good comment, Sheldon. As a project manager of that project, the project number is 4664. So we're in the process of the publication of the final report. So you will be able to see the final product soon. Yes, as Sheldon mentions, there is a great communication piece, how the utilities communicate with their customers, to the building owners or the homeowners. There is great information in the project report. But just wait for a little bit, and so we're working on it for the final report. So I think that is it. That's it for today. Just for the quick announcement, the third webcast for this webcast series has been scheduled on December 4th about the Legionella management and guidelines. So please check your inbox for your the next webcast announcement. As you mentioned, the slide and the recording of this webcast will be available on the Foundation website. The questions that we could not answer during this webcast will be answered by emails. So I would like to thank each of the speakers who are willing to present and share their knowledge with the audience. And thank you for joining the webcast today. And please do complete the follow-up survey so that we can get your thoughts for the future webcast. And once again, thank you and enjoy the rest of your day.